Hello everyone, welcome to the BYJU'S Exam Prep, the most comprehensive app for all competitive exams. How are you guys? Let me know that sound quality, picture quality, everything is fine. Now, this is a network part 1 and we are going to discuss all the previous year questions by IIT Kanpur. It is IIT Kanpur previous year question series, right? And we have some conceptual questions from network, right? And we will discuss almost all the questions from electronics and electrical branch, and we will try to cover what questions from instrumentation branch also. Okay, so are you ready to solve some important questions? If yes, then please like the session, share the link of this session and subscribe our channel. Okay guys, let me know that sound quality, picture quality, everything is fine. First of all, inform me that sound quality, picture quality, everything is fine. Yes, please. Give me 1 minute. Okay, I think everything is fine now. So, Passion of Art, Mansi Agrawal, welcome to the session. And then, this is a previous year question series, and that is my introduction. Myself, Sanjay Rathi. I'm having around 21 plus years of teaching experience, and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ECE 2005 and AIR 21 in ECE 2008, right? And I have mentored more than 1 lakh students for these competitive exams. Everything is fine. Thank you, Passion. And okay, now some important numericals we are going to discuss. Give me 1 minute. 1 minute. And this is important information for you. Free workshop strategy to get 100% MSQ correct in GATE exam by 14th on 14th August at 12:30 p.m. Please note this time. This is very important session for you. That is by Abhinav Negi sir. Okay. So on 14th August 12:30 p.m. and important session on MSQ. Multiple select questions. I am fine, Raghuram. How are you? Then that is the first question. We will cover questions from 2015. That is the GATE conducted by what? IIT Kanpur. Then what? 2007 and then 2001. Okay. And then first of all, we will discuss questions from the basics and then from the theorems. That is the basics means what? KCL, KVL. Okay. And then theorems. Thevenin's theorem, Norton's theorem, maximum power transfer theorem, superposition theorem, AC plus DC both. And after that, two-port network. Okay. And in part 2 means tomorrow at the same time 7 p.m. we will discuss questions from transient, first order transient, second order transient, and what questions from resonance and miscellaneous topic like what? Graph theory, okay, network function. So we are having some 1 or 2 or 3 questions from graph theory, right, or network function. So tomorrow we will discuss. So today we are going to discuss from basics, KCL, KVL, mesh analysis, nodal analysis, right, and theorems and two-port network. Ready guys? So first question on screen. In the given circuit, the values of V1 and V2 respectively are V1 and V2. This is the V2, right? The voltage across the 5 ampere current source. V1, this is the voltage across the dependent source. What is the value? That dependent source is what? 2I. 2I means it is also a current source. It is also a current controlled current source. You have to find the value of V1 and V2, then which answer is correct? That is the only 1 mark question, set 1 in 2015 electronics branch. Yes, please, everyone. Try to give me the answer. And please use your notebook, right? Copy, calculator, virtual calculator. Okay, try to solve all this question. Okay then, everyone. Now, very simple means we are having the question from what? Basics. Basic of network. That is 5 ampere current source. We have to solve this simply. Let this voltage is V1. What is the voltage at this point? V1. What is the voltage at this point? This is nothing but V1. Now what is the value of I here? I is equal to V1 by 4. I is equal to what? V1 by 4. Then this 2I will become what? V1 by 2. So we can write in place of 2I, we can write V1 by 2. That is the current. And what is the voltage across this 2I? V1. Okay. We have to calculate V1 and V2. Now we are going to apply what? KCL. That is the Kirchhoff's current law. And we will apply what? Nodal analysis. So what is the nodal analysis so that we can find the value of V2 and V1? For example, what is the incoming current towards the V1? 5 ampere. 5 ampere is the incoming current is equal to, what is the outgoing current? V1 by 4, that is nothing but I, plus V1 by 4 plus 2I. This is the 2I. Now we can write 5 is equal to 3I plus V1 by 4. As you know, what is the I? I is nothing but V1 by 4. So we can write 5 is equal to 3 into V1 by 4 plus V1 by 4. This is the 3 by 4 plus 1 by 4. 3 by 4 plus 1 by 4 will become 1. So what is the value of V1? 5 volt. Very simple nodal analysis. Yes, you are giving the right answer. V1 is what? 5 volt. Yes. And now how to calculate the V2 here? V2 is nothing but, that is the 5 ampere current. If you want to write the V2, you can write the KVL from this point to this point. What is the current here? 5 ampere. So what is the drop? 5 into 4, that is the 20 volt. Write down the KVL from this point to this point. When I am writing the KVL, it will become minus V2. This is the minus V2 plus 20. Because it is a 5 ampere plus 20 plus V1 is equal to 0. So what is the V2 is equal to? 20 plus V1, that is nothing but 25 volt. Very simple. Very, very simple question. 1 mark question. And that is answer is what? A. Answer is A. Yes. So you are giving the right answer, everyone. V1 and V2. So very simple question. First question from nodal equation. Okay. And that is the case. Now second one. Second question. So that is the answer for this question is what? 5 volt and 25 volt. Now, questions to find what are equivalent. Normally this type of questions in what? Class 11th and class 12. But we are getting the question to find the R equivalent in this diagram in 2015 1 mark question again. 1 mark question here. Now, what is the answer for this one? Yes, Vipul, Viswas, your answer is also correct. Now, एक बार जरा शेयर कर दीजिए. Please like the session, subscribe our channel because daily we are going to take all the questions from what? Analog, network, after that signal and system, digital already taken by what? Rakesh Talreja sir. We will discuss previous year question that was conducted by what? IIT Kanpur. This is the 2015 1 mark question. What is the answer? In the network shown in the figure, all resistors are identical with R is equal to 300 ohm. The resistance RAB of the network is, what is the RAB of the network? All are the equal resistor. Okay. Now in this case, we are using the fold back symmetry, that when we are folding this is the symmetrical diagram. So what is the meaning of the symmetrical diagram? Very simple. Let for example, this is the current here. This current is I1, this current is I2. Because of the symmetry, what is the current at this node? This is the I1. What is the current at this node? That written back is what? I2. Right? So what is the current? When same current I1, same current I2, so what is the current in this branch? 0. Similarly, let this is the I3. Since it is symmetrical, so what is the current here? I3. If it is I4, so what is the current here? I4. If it is I5, what is the current here? I5. If it is the I6, what is the current here? I6. Means, because of the fold back symmetry, what will be the distribution of the current, everyone? That is the distribution of the current. I1, this is the I1, same current, I2, I3, I4, I5, I6. So what is the current through this branch? Current through this branch is 0. When the current through this branch is 0, we can remove this branch. When we can remove this branch, new students, please try to understand this concept. When we can remove this branch, so what is the equivalent diagram for this one? Now, this is the RR. Okay. Now here, we can remove this branch. So these are in parallel. These are in parallel. Again, this R. All R, and last, finally, this is the R and R. Okay, guys. Now you have to find the R equivalent. Now, watch this. This is R, this is R, this will become 2R. That is in series. This is the R by 2, this is the R by 2 because all are R. R by 2, it will become R. R by 2, it will become R. And again, it is a 2R. Now, 2R parallel with 2R is R. This is R, this is R. So, what is the R equivalent? R equivalent is nothing but R by 3. 300 divided by 3. So, what is the answer here? 100 ohm. Answer here is 100 ohm. Easy? Right. So, this is the method. If it is a fold-back symmetry, then simply you can remove this branch. You can remove this branch and this question will become very, very easy for you. Okay. That is the answer is what? 100 ohm. So, how many students are getting this question? Comfortable with this type of questions? Means we can get one questions from what? Calculate the R equivalent or calculate the C equivalent or calculate the L equivalent. Right? If you are not comfortable, then you can solve some important questions from what previous year, standard textbook. You can follow any standard textbook. Okay? And try to solve 5 to 10 questions. You will get the idea. Okay. That is the answer. Next one. Now, again, this is the question in set 3. That is the question in 2015, 1 mark question in set 3. In 2015, there were 3 sets. Set 1, set 2 and what? Set 3. So, yes, please give me the answer for this question. In the circuit shown, the voltage Vx in volt is. What is the value of the Vx? Now, number of students are not comfortable with what? Dependent sources. Okay. Don't worry about the dependent source. It is a very, very simple question. We can directly apply the nodal analysis or mesh analysis. Right? Right. Try to understand. But this is the Vx. Actually, this is the Vx. This is the voltage source. This is the 0.25 Vx. What is the what is the current here? 0.5 Vx. What is the current here? 5 ampere. We have to find the voltage. Simply, let this is the reference. Let this is the reference. When this is the reference, what is the voltage at this point? 0.25 Vx. 0.25 Vx. Because it is a voltage source, this is the reference, then 0.25 Vx. What is the voltage at this point? This is nothing but Vx. This is nothing but Vx. Okay. Then simply you can write a KCL at this point. When I am writing the KCL at this point, what is the incoming current at this node? These two nodes are same node because there is short circuited. So these two nodes are same node. So what is the voltage at this point? Vx. This is the same node. Now write, what is the incoming current? 5 ampere. What is the outgoing current? Vx by 20. What is the outgoing current? 0.5 Vx. What is the outgoing current? Vx minus 0.25 Vx upon 10. Right, that is a KCL. That is a very simple KCL. Vx 5 ampere, Vx by 20, Vx minus 0.25 by 10 and 0.5 Vx. Okay. Now, everyone give me the answer in comments box. You can write it like this: Vx by 20 plus Vx by 2 plus Vx minus Vx by 4 upon 10. Okay. Now you can write Vx by 20 plus Vx by 2 plus 4Vx minus Vx upon 40. This is the 4Vx minus Vx upon this 40. Now you can take 40 as a LCM. Then it will become 2 plus 20 plus 3Vx. Okay. This is 200 and this will become 3 plus 2, 25Vx. What is the value of the Vx then? Vx will become 200 divided by 25. What is the answer? 8 volt. What is the answer? 8 volt. Yes, passion of art. You are giving the right answer. Okay then. So please, Vipul Viswas, check your calculation. Don't worry. Okay. There may be some silly mistakes. So please check your calculation. So very simple. Take it as a reference. So don't worry about the dependent source. It is a voltage controlled voltage source. Right? And this is a voltage controlled current source. In the same diagram, we are having the two dependent sources. Directly we can apply the KCL at this point. This is the incoming and that is the outgoing, and we are going to get the answer 8 volt. Okay, easy. Now next one. Next question. The voltage E0 in the figure is. So in 2015, that next question was very easy one. What is the E0? E0 in the figure is means we have to calculate the voltage at this point. Very simple. Right? Always this is the LED, this is the reference. This is the E0. Let this voltage is E0. Directly you can apply the KCL or you can apply the voltage division rule. It depends upon you. I will give you the two methods. When we are going to apply the KCL or nodal equation, E0 minus 12 by 4 plus E0 by 4, I am taking it as a reference. These two resistors are in series. E0 by 4 is equal to 0. 4 is the common. This will become 3 E0 minus 12 is equal to 0. So what is the E0 is equal to 12 by 3. What is the answer? 4 volt. Okay. Please check my calculation. Please check my calculation. 1 marks question. Yes, Vipul, your answer is correct. 4 volt. This is the 4 volt. Voltage E0 in the figure is 4 volt. Second thing, sometimes very fast we can solve this question. Right, this is the 2, this is the 2. It is connected in a parallel. 4 parallel with 4 is nothing but 2. No need to make the diagram, but just simply. This is 4, this is 2. And the voltage across the parallel combination will remain E0 because it is parallelly connected. 4, 2 plus 2, 4, 4, 4 parallel, it is the 2. You can simply apply the voltage division rule. 12 divided by 4 plus 2 into 2. What is this? 12 divided by 6 into 2. That is nothing but 4 volt. So this is the second method. This is the method 1. This is the method. Directly observe the figure. Calculate the equivalent resistor parallel connection. Voltage division rule. Voltage division rule. You are going to get the 4 volt. Very simple 1 marks question here. Okay, that is in a previous year question of yes, right. Now what is the answer for this question? Tell me. This type of questions in a different sets we are having that this type of question in 2001 2 marks. Similar type of question in what 2015, right? What is the answer? The voltage E naught in the figure is 8 ampere current source is given here, 10 ohm, 2 ohm, 6 and 16 volt, they are connected in series 12. Now we have to find the E naught. Then, my dear friend, 8 or 10, you can also apply what? Source transformation, right? Source transformation is a very easy one, and then apply the nodal, or directly you can go for what? Source transformation. Yes, please. So when I am applying the source transformation, what will be the answer? Tell me now. 10, 2, 6, 16 and 12. After source transformation, 8 into 10, that is what? 80. 10 ohm in series. This is 80 volt. In source transformation, simply multiply this what? 10 into 8, 80, and then this is in series, 10 ohm, 2 ohm, then this is the 16 and 6, you can change the position. You can change because these two are connected in series, 6 ohm, and this is the 12. Right. Now you have to find this E naught. E naught means this voltage is also E naught. Okay. Directly apply what? Nodal. Now we have simple one node, that is the reference node, and so on. Apply the KCL. E naught minus 80 divided by 12 plus E naught minus 16 divided by 6 plus E naught by 12. What is the LCM here? 12 is the LCM. It will become E naught minus 80 plus 2 E naught minus 32 plus E naught is equal to 0. Now this 12 will become 0. 2 plus 3 plus 4 E naught is equal to 80 plus 32, 112. 112. Now what is the E naught? 112 divided by 4, I think it is what? 28? 32, that is the 28 volt. 28 volt is the answer for this question. Very simple. You first, some students, if I am going to give you the hint that source transformation, from first to last you will apply the source transformation, then it will become very lengthy. So one, use the concept of source transformation up to this point, and after that we have only one node. If we have one node, directly you can go for what? Nodal analysis. Directly nodal analysis, directly one KCL, and you are going to get the right answer for this question, that is the 28 volt. This is the 28 volt answer for this particular question. Okay. Next, this type of questions. Okay. 28. If you have any doubt, then you can ask. These are the questions from electronics branch. Now we are going to solve some questions from what? Electrical branch. Electrical branch. So electrical branch, this is the question. The voltages developed across in 2015 1 mark question, set 1 from electrical branch. Yes, your answer is correct, Passionova, right? Your answer is correct, 28 volt. The voltages developed across the 3 ohm and 2 ohm resistor. 3 ohm, where is the 3 ohm? Here it is a 3 ohm. This is the plus, this is the minus. Shown in the figure are 6 volt and 2 volt respectively. The voltage is the 6 volt, it is given in the diagram. Voltage here given is the 2 volt, it is also given in the diagram. With the polarity as marked, what is the power delivered by the 5 volt source? What is the power delivered by the 5 volt source? Where is the 5 volt source? This is the 5 volt source. Any idea about this network, that network? No idea. What about this network? What are the components? We have no idea. this network we have no idea. Then remember, KCL, sum of the incoming is equal to what? Sum of the outgoing current. We can apply the direct KCL here. So this is just like a point. In a point, we are having the current here. For example, this is a 6 volt battery. Then we can say, what is the current here? Let this current is I1. And this will develop for 6 volt across this. So I can write 3 into I1 is equal to 6 volt. So what is the value of the I1? 6 by 3, that is 2 ampere. Okay. Now, what is the polarity? Plus minus. Let this is the I2. So I2 into 2 is equal to 2 volt. 2 into I2 is equal to 2 volt. So what is the I2 is equal to 1 ampere. Okay. This current is 1 ampere. So what is the current here? If it is power delivered, always remember, if the power delivered is asked, let this is the I3. Let this is the I3. So what is the, when I am writing the KCL for this, what is the outgoing current? I1. What is the incoming current? I2 and I3. So we can write outgoing current is equal to incoming current I2 plus I3. I2 plus I3. Then simply we have to find the I3. What is the value of the I3? When I am going to write the I3, I1 minus what? I2. I1 minus I2. So what is the I1? 2, 1, and that is what? 1 ampere. Okay. Once you have the value of what? I1, simply what is the power delivered by the source? Because current entered through the minus, leave the positive. What is this value? 1 ampere. Definitely it will deliver the power. Normally we are showing like V and I. So 1 into 5, that is 5 watt. We are not going to use the minus sign. Why? We are not going to use the minus sign because it is already asked what is the power delivered. That is the 5 watt. Answer A. What is the power delivered? It is used. But what, according to sign convention, if the current enters through the negative, leave the positive, the power will is what? Negative. And when we are getting the negative power, means it is delivered by the particular element. Okay. Okay, no issue. कोई problem नहीं है. Solve करते जाओ passion. No problem. If you have idea how to solve the question, okay, it will give you the confidence. Okay. So Subham, your answer is correct. Vipul, your answer is correct. No problem. No issue. Then, very, very simple question. Next one. In the given circuit, the parameter K is positive. Parameter K is what? Positive. And the power dissipated in the 2 ohm resistor is 12.5 watt. Where is the 12.5 watt power dissipated across 2 ohm resistor? This is the 2 ohm resistor. Is 12.5 watt. The value of K is, you have to find the value of the K. At this point, what is the value of the K? Okay. Then, simply tell me, if you have the idea, this is the, okay, I think there is a, please try to solve this question, everyone. Try to solve this question. Just I am giving you the time. Give me the answer. 2 ohm, 5 ohm, 4 ampere. 1 minute, I have to check this. Okay. Yes, this is a 4 volt source. Yes, now please try to solve this. Okay, bataiye, what is the value of K? 4 volt, people. This is a 4 volt. Actually, if it is a 4 ampere, then the power dissipated across it will become what? 4 square, that is a 16. 16 into 2, 32 watt. But what is the power dissipated? It is given 12.5 watt. So definitely is a 4 volt. If it is a 4 volt, then what is the value of the K? Try to understand. So what is the power given? 2 ohm, 12.5 watt. Okay. So what is the power dissipated? We can say power dissipated across the 2 ohm resistor is given by V0 square by 2, because V0 square by R. It is given as 12.5 watt. So what is the value of the V0? This is nothing but root over 2 into 12.5, that is 25, that is nothing but 5 volt. We can find the value of V0 here. Once you have the idea about the V0, then what will be the current we can apply, or we can find the voltage at this point. What is the voltage at this point? Sorry. One minute. This is a 4 volt, this is the 2 ohm, 5. Now try to understand. This is a 4 volt. This is 5. Already we have 5. So my dear friend, what is the voltage at this point? -1. You can write -5 plus 4. What is the voltage at this point? -1. Directly now you can give what is the incoming current here? kV0. This is the current source. So what is the current here? kV0. What is the outgoing current? 5 ampere. And what is the current here? 5 by 2. So 5 by 2, already we have 5. What is this? 5 by 2. So what is the current? 2.5. Incoming, outgoing, you can find the value of the K. So what is the incoming current? 2.5. What is the incoming current plus kV0? What is the outgoing current? 5. Tell me. And we have the value of the V0 also, 5 volt. So this will become K 2.5 divided by 5, that is nothing but 1 by 2. What is the value given? 0.5. Yes. No passion of art. Check your calculation. I have given you the enough time. Okay. Check your calculation. Yes, please. This is a 1 by 2. Very simple. Find the voltage at this point. Find the current. Apply the KCL. Directly what is the incoming? Sum of the incoming current is equal to outgoing. Then you can find the value here. 1 by 2. Okay then. Next question. Next one. Now, this is a question. This type of question, 1 mark question. That is connected here, that is a zigzag and so on. We have to find what the current I in a 2 ohm resistor of the given network is. What will be the current here? Everyone tell me. Yes, please. That is the circuit, 1 ohm. This is the circuit. This is the case. Yes, please tell me. Okay. In this diagram, watch this diagram carefully. This is not connected here, no? This is because that dot is given, big dot is given, means this is connected. There is no connection, no jumpers. Normally we are giving like this. It is not given. Right? But this is connected, this is connected, this is connected, this is connected, means this is not connected. Very simple. And now, if we are giving the point, like this is the A, this is the B, this is the C, and this is what? D. So we are connecting the battery between what? A and C. Okay, no issue. We are connecting the battery between A and C. A and C battery is connected here. What is the value of the battery? 5 volt. This is the DC source or AC source, that is given 5 volt. Simply we can apply here. Now, this is the point B. This is the point B. And this is the point D. This is the A. This is 1 ohm is connected here. 1 ohm is connected here. Between A and B, between B and C, it is visible. Between B and C. Now between C and D, 1 ohm is connected, B and C, 1 ohm is connected here, A and D. This is the A and D, 1 ohm is connected. 1 ohm is connected here. Now between B and D, 2 ohm is connected. So this is a question on the bridge. Question on bridge means what? Yes, your answer is correct. That is what? 0 ampere, Sanjay. Right? So your answer is correct because that particular bridge is balanced. If it is a balanced bridge, what is the current through the 2 ohm resistor? It will be 0. R1 by R2 is equal to R3 by R4. And that's why, what is the current through the 2 ohm resistor? It will be 0 ampere. Yes, Jaya, your answer is also correct. Now, next one. So this type of questions, what's the question? Some students are not comfortable. I am not going to give you the short tricks and so on. Simple method, how to check the diagram. If suppose it is not possible in exam hall, then use the fundamental concept A and B. A, B, C, D and so on. You can check the diagram and you can redraw it, get the idea. Okay, so that is the question. Now next one. 3 volt DC supply with an internal resistance of 2 ohm. 3 volt DC supply with an internal resistance of 2 ohm. This is the DC supply. A passive non-linear resistor, any resistance, passive non-linear resistance characterized by the relation V no load. This is called INL square is equal to INL square. That is the relation. This is the voltage across that non-linear, sorry, no load. No, that is not the no load. This is a non-linear resistor. NL for non-linear. The voltage across that resistor is what? This is the non-linear resistor. So VNL, and what is the relation? It will not follow the Ohm's law. So VNL is equal to what? INL square. VNL is equal to INL square. INL is nothing but current through that resistor. I think that diagram is clear, everyone. That diagram is clear to you. So first of all, non-linear resistance INL. This is the VNL. This is the battery. And what is the value of the battery? 3 volt. What is the internal resistor? 2 ohm. This is a 3 volt battery. Directly you can connect 3 volt battery. Resistor is what? 2 ohm. Okay. And then the power dissipated in a non-linear resistance. What is the power dissipated? Power dissipated is given by VNL INL. We have to find this. We have to find this. And what is the VNL? VNL is nothing but INL square. When I am putting the INL square, the power dissipated will become INL cube. We have to simply find the INL, then find the cube of that. We have the diagram, we have the relation. Directly write down the KVL and you are going to get the answer for this particular question. Okay, 1 minute, give me 1 minute. Please everyone give me the answer. Give me 1 minute. Yes, please. Right. This is the 2 ohm. This is the 3 volt. What is the INL is equal to? INL is nothing but 3 minus VNL upon what? 2. Simple. This is the voltage 3 volt. This is the voltage VNL. 3 minus VNL upon what? 2. That is the INL. Right here, 2 INL is equal to 3 minus INL square. It will become a quadratic equation. What is the quadratic equation? INL square plus 2 INL minus 3 is equal to 0. Right? Then we can write it like this. INL is square plus or minus. So everyone tell me, what are the roots here? What are the roots here? You are going to get the INL is equal to 1 ampere or INL is equal to what? Minus 3 ampere. 1 ampere and what? Minus 3 ampere. Okay. If it is this current is 1 ampere and minus 3 ampere, what is written in the question? Watch the question carefully. The power dissipated in the non-linear resistor. Right? What? Internal resistance passive supplies a passive non-linear resistance. If that particular resistor is passive element, the current is what? Always 1 ampere, positive. We can't take it what? Negative value. Right? Active source, it may be negative, but it is written passive. So passive means what? Same current will enter through the plus, leave the minus, and that's why it is a passive element. Current is what? 1 ampere. You can reject it because it is a passive. There will be the power dissipation, and then what is the power dissipation? Already I have given you the formula INL cube. INL cube means what? 1 cube. That is nothing but 1 watt. Answer for this question is 1 watt. Yes, Sanjay, your answer is correct. Hema, very good evening. How are you? Now, everyone try to give me the answer, or एक बार जरा please share the link of this session in your group so that a student will join. That is just a practice session, and we are getting the idea which type of questions they may ask and what are the different approaches to solve particular question. Okay, very simple. So 1 watt, that is a no load, that is a non-linear resistance. And this session is important for what? Electronics student, electrical students, instrumentation branch. When network is common in what? Electronics, electrical and instrumentation, right? And that's why I'm trying my best to cover the questions from electronics branch, electrical branch, as well as what? Instrumentation branch, so that you will get idea. Right? Normally we are solving the suppose we are from electronics branch, so we are solving questions, previous year question of electronics only. But network is common subject, network or circuit theory in electronics, electrical and instrumentation. To try to solve all the previous year questions of what? Electronics, electrical and instrumentation branch. Okay, if you have time. Okay, then that is the answer. Good question. And what is the answer? A. 1 watt. Next, in 2007. This is a question in 2007. 2 marks question. Okay. Next. 2 light bulbs, right? 2 light bulbs of 40 watt and 60 watt ratings are connected in series across the mains. Tell me, what is the concept of the bulb? Everyone, you have idea about the concept of bulb? 2 bulbs are connected in series. The first answer, the bulbs together consume 100 watt. The bulbs together consume 50 watt. The 60 watt bulb glows brighter and the 40 watt bulb glows brighter. So these are the options. Right. Now watch this. Let we are connecting a voltage source. There are the 2 bulbs. Normally we are representing like this. No issue. Now what is the rating? 40 watt and 60 watt are connected in series across the mains. Now, nothing is given about the voltage. If nothing is given about the voltage, means voltage rating is similar. So normally the bulb is represented like this. The voltage rating is what we are normally saying, that 230 volt, and what is the bulb rating? 40 watt. Normally, same rating here, 230 volt, 60 watt. So what is the resistance here? Resistance, what is the power? Actually, power rating is given by V square by R. It will become V square by R2. Voltage is same. So what is the resistor here? V square by P1. What is the resistor here? V square by P2. Okay. Now, what about the resistance? P2 is greater than P1, then definitely P2, or we can say P1 is less than P2, so we can say R1 is greater than what? R2. Now, these two are connected in series. Its resistor is R1, its resistor is R2. We are going to have the same current in the series, I. And what is the I? I is nothing but Vs upon R1 plus R2. That will be the current. Okay, we are having the same current. So what is the power dissipation across the bulb? The power dissipation across the first bulb will become I square into R1. And power dissipation across the second bulb will become I square R2. Since the R1 is greater than R2, and that's why the power dissipation across the first one is greater than power dissipation across the second one. So which one is the brighter? Which one is the brighter? Brighter means more power dissipation. 40 watt bulb glows brighter. 40 watt bulb glows brighter. Now, remember this concept. Within 10 seconds, we have to solve this question. Okay. If the two bulbs are connected in series, then always, if the voltage rating is similar, in this question, voltage rating is not given. So normally we are taking the same voltage rating. Normally in our houses, what is the RMS value? 230 volt RMS or 220 volt. And that's why the 40 watt bulb. If these two bulbs are connected in parallel, always remember, all the connection in our houses are, all the bulbs are connected in what? Parallel, like this. And this is the voltage. In that case, current will be different. It depends upon the voltage, because we are having the same voltage, like this is the R1 for 40 watt. This is the 60 watt. So what is the power dissipation in this case? Since the voltage is same, it will become V square by R1. V square by R2. Means simple. 60 watt will be brighter, 40 watt will be less. Okay. Easy, guys. Easy. In a parallel, 60 watt bulb glows brighter. Now, in the circuit shown, the Norton's equivalent. Now, some questions from theorems. Circuit shown, the Norton equivalent resistor across the terminal AB is. Norton's equivalent resistor means simply, this is a 2 ohm, sorry. This is a printing mistake. This is a 2 ohm resistor. Everyone give me the answer. Very simple question. But here it is a dependent source. If it is a dependent source, number of students will make what simple mistake. What will be the mistake? You will take the 4 ampere as 4 as a short circuited. If it is a voltage source, short circuited. If it is a current source, open circuit. And definitely some students will find simple R equivalent. But when there is a dependent source and when we want to find the I, what is the method? What is the method here? Everyone, we have to connect this is a 2 ohm. We have to connect a battery of 1 volt or V volt. You can choose V volt battery or 1 volt battery. Let this current is I1. Why I am choosing the I1? Because I is given here. So what is the RN or RTH? Norton's resistance or Thevenin's resistance, 1 divided by I1. What is the value of the battery divided by the current given by the battery? It will give you the value of RL. Okay. Everyone try to solve this question. Now, if this is the 1 volt, so what is the voltage at this volt? 1 volt. Very simple. What is the incoming current? So what is the I? First of all, what is the I? I become 1 by 4. 1 by 4 ampere. If it is 1 by 4, so what is the 4I will become? 4 into 1 by 4, that's why it will become 1 volt. This is nothing but 1 volt. Okay. Now, very simple. You can apply the KCL, or simply we are applying the nodal analysis. So what is the incoming current? I1. What is the outgoing current? 1 by 4. What is the outgoing current? 1 by 2. What is the outgoing current? 1 minus 1 by 2. So it will become 0. Now, you can take 4 as an LCM. So it will become 1. It will become 2. I1 is equal to 3 by 4. This is not the RTH or RN. What is the RN? 1 by I. So what is the 1 by I? 4 by 3 ohm. 4 by 3 ohm. Very simple question. Norton's equivalent. So very easy. Simply apply the 1 volt battery, 4, 2 ohm, 2 ohm, and this is the, first of all get the idea what is the I, 1 by 4, replace this by 1 and simply apply this nodal equation, and this is the 4 by 3. 4 by 3 means what? 1.33 ohm. Up to 2 decimal places if it is asked, 1.33 ohm you can write the answer for this question. Right? Because it is a NAT type question, numerical answer type question, up to 2 decimal places means 1.33 ohm. Okay. Easy guys. Any doubt then you can ask. Anyone. If you have any doubt then you can ask. So this is the Norton's equivalent with dependent source. Now, same in set 3, 1 mark question. For the current shown in the figure, the Thevenin's equivalent voltage across the terminal AB. What is the Thevenin's equivalent voltage? That is again the question from what theorems? Thevenin's theorem. What is the VAB? Now, remember that Thevenin's voltage means what? Open circuit voltage. Thevenin's voltage is nothing but open circuit voltage. If you want to find the open circuit means what is the current in this branch? It will become 0. First of all, remove the RL. Already in this question there is no RL. You can remove the RL. Then you have to find the VOC. Some student will apply what? Source transformation and so on. But very simple one. You can directly apply the nodal at this point. So you can write like this voltage is VOC. Apply the KCL. We have only one node. This is the reference node. VOC minus 12 divided by 3. VOC minus 12 divided by 3 plus VOC minus 0 by 6, VOC by 6. These are the outgoing current. VOC minus 12, this is the outgoing current. This is the outgoing current is equal to incoming current. What is the incoming current? 1. You can take 6 as a LCM. Everyone give me the answer. 2 VOC minus 24 plus VOC is equal to 0, is equal to 1, not 0. Now this will become 3 VOC minus 24 is equal to 6. So VOC is equal to 30 upon 3. What is the answer given by the Lakshman? Yes, your answer is correct. Right, Lakshman, your answer is correct one. Right. Now this is the answer, 10 volt. Okay. Well, some students will apply what? Source transformation. Yes, you can apply the source transformation. Then after that we have to apply what? Current division rule. Then we can find the value. But simply directly we can solve use of what? Nodal equation. Directly in one step we can get the answer for this question. Okay. Actually what? In source transformation we have to redraw the diagram. Suppose we want to avoid the silly mistakes, then every time we have to redraw the diagram. If you are comfortable with the source transformation, okay, no issue. Right. That is the method. Source transformation means what? 12 divided by 3, that is the 4 ampere. This is the 3 ohm in parallel. 1 ampere in parallel. And this is the 6 ohm. Okay. Now 1 and 4 are in parallel. 12 divided by 3, 4 plus 1, 5. What is this? 5 ampere. What is the resistor? 6 and 3. This is the 3 ohm resistor. 3 and 6 are in parallel. That is nothing but 2 ohm. Now when it is multiplied, again convert it into a voltage source. So 5 into 2, that is the 10 volt. And this is both. This is nothing but RTH. This is nothing but VTH. This is called source transformation method. Source transformation method. We can use this. It depends upon you. Right. Okay then, next one. Next question. Again, in a 2007 2 marks question from the Thevenins for the circuit dependent source. Remember that this is a dependent source. This is the 2 ampere current source, 2 ohm. For the circuit shown in the figure, the Thevenin voltage and resistance looking into the X and Y are. Okay, in 2007. In 2015, what was the level of the question? Very easy. Very simple question in 2015, but in 2007, we have to find the Thevenins with the dependent source. Okay. Okay then. So we have to solve minimum 15 to 20 years previous year question paper. Minimum 15 to 20 years. So in that is the question designed by what? IIT Kanpur in 2007. Tell me. For the circuit shown in the figure, the Thevenin voltage and resistance looking into this circuit. Okay. Now, when both VTH and RTH is asked, read question carefully. Try to solve on your copy. Everyone, try to solve this question. Tomorrow we have the same session at 7 p.m. 7 p.m. 7 to 8:30 p.m. Right? And we are going to discuss questions from what remaining topics like what two-port network. Right? Today again I will discuss some 1 or 2 questions from the two-port network. Then what steady state analysis of the sinusoidal signal, network function, graph theory, and most important is what? Transient. First order transient and second order transient. And questions from resonance, series resonance and parallel resonance. Okay. What is the answer? Now, this is a 2I. It is a voltage control, current control voltage source. 2I means current control current source, voltage source. First of all, you have to find the VOC. Very simple, you can write the VOC here because it is a single node. Let this is the reference node. Right. Now, what is the I? We can give I is nothing but VOC upon 1. So this is nothing but VOC. So directly you can write that 2I is nothing but 2 VOC. Replace it. 2I is equal to 2 VOC. Write down the KCL at this point. Simply nodal equation. So what is the incoming current? 2M. What are the outgoing? VOC minus 2 VOC. Upon what? 1. Plus VOC by 1. VOC by 1 plus VOC by 2 is equal to 0. No, sorry, is equal to already it is 2. Easy guys. VOC minus 0 by 2, VOC minus 0 by 1, VOC minus 2 VOC by what? 1, and already I have replaced this VOC and that is the incoming current. Now, tell me, you can take the 2 as a LCM, so it will become, try to avoid the silly mistakes, VOC minus 2 VOC, sorry. This is already minus VOC multiplied with this, so minus 2 VOC. Plus 2 VOC plus VOC. This is cancelled out. What is the VOC? 4 volt. VOC is the 4 volt. Which answer it is a 4 volt? In the option B or in the option what? D. There is a 4 volt. Now we have to find what is the RTH. Now already we have the value of VOC. Then we will use the formula RTH is equal to what? VOC upon ISC. VOC upon what? ISC. So VOC upon ISC means simply find the short circuit current. When we want to find the short circuit current in this diagram, very simple one. Okay, for this right, for PDF of this session, please join my Telegram channel. That is what Electronics by Sanjay Rathi. Just after 2 minutes, I will share the link of that Electronics by Sanjay Rathi. Join that Telegram channel so that you will get the PDF of all this session, solved example, unsolved, everything you will get. Okay. Now, once you have the VOC, what is the value of the VOC? 4 volt. Then you can find ISC. Directly make it what? Short circuit. Very simple. What is the ISC? When this is the ISC, it will become short circuit. What is the voltage at this point? This voltage will become 0. Then this is 0. So what is the value of I? I will become 0. 0 by 1, 0. This 2I will become 0. But this is I 0, 2I 0. So what is the current through this? 0. What is the current through this? 0. What is the current through this? 0. So what is the ISC? ISC is nothing but 2 ampere. This complete current will become ISC directly. So we have the value of the VOC, we have the value of ISC. So what is this? 4 divided by 2, that is the 2 ampere. 2 ohm. 2 ohm. Which answer is correct? B or C? Everyone give me the answer. Which answer is correct? Sir, in the bulb question, will they both does not consume 100 watt? Maladi, it depends. What is the voltage given? What is the voltage given? Any information is given about the voltage. Which statements are best? We have to choose the best answer. Are you getting my point, everyone? We have to choose the best answer. Right? Maladi. Praharsa, you have that? Yes. First of all, what is the answer for this question? D. Check your calculation, everyone. Now, I am not connecting the battery. Why I am not connecting the battery of 1 volt and so on? I am not connecting the battery of 1 volt because what? We have to calculate the VTH and RTH both. So already I have calculated the VOC, then it will become very easy to calculate what ISC, and that is the another definition of the RTH or VTH, RTH or RN, VOC upon ISC. That's why simply use this short circuit and directly you are going to get the 2 ampere. No need to connect a 1 volt battery or 1 ampere current source. Again, the question will become very lengthy. If only RTH or RN is asked, then you can apply. Okay then. Now what is the question? What is the problem with the bulb? Right. देखो लिखा ना 2 light bulbs of 40 watt and 60 watt rating are connected in series across the mains. The bulb together consume 100 watt, bulbs together consume 50 watt. Now, if the 40 watt bulb glows brighter, what is the meaning of this? Tell me. What is the meaning of this? Brighter means it is giving the more power as compared to 40 watt. What about the 60 watt bulb? Lesser, right? If it is connected in parallel or we are giving the same supply, for example, main supply 230 volt. And the reading is also given 230 volt. So what is the power consumed? 60 plus 40, it will become 230 volt. Suppose we are connecting these are in series. You can calculate it. V square by R1, V square by R2, that is the value. You can put the value 230 volt, 230 volt, get the value of R1 and R2. And then, my dear friend, calculate the power dissipated across that. Power dissipated across gate, you are going to get the different power. Okay, Praharsa, you can check. You can check. We are applying the same voltage here, 230 volt. For example, that the supply is also same, 230 volt. That rating is also same. But according to voltage divide rule, the voltage across these two will be different. And that's why in series, the current is same. That's why you have to calculate the current. Already it is given, na? R1 by R2. 230 divided by R1 plus R2. Use this 230 volt here. Find the value of the R1. Find the value of the R2. Everyone, please solve this question and you will get the idea. Okay, easy. If you have any doubt related to bulb, simply everything you can calculate on the basis of this calculation. Very easy. Okay. In a parallel, yes, if we are giving the same supply, that is the 230 volt means, then total power consumption is what? 60 plus 40, that is what? 100 watt. Okay then. Next one. Now tell me what is the answer. For the given circuit, the Thevenin's equivalent is to be determined. The Thevenin's voltage seen from the terminal AB is round off to 2 decimal places. Now what is given? For the given circuit, the Thevenin's equivalent to be determined. If you want to determine the Thevenin's equivalent, now my dear friend, it is a time for what? It is the time for assignments. Ready guys? Homework. Right, because I have one session, so this is the homework for you. Tomorrow I will give the answer, complete solution on this question. Very simple. 2 volt, 1 ohm, 1 ohm, 20i, 2 ohm, and I am going to share what my Telegram channel link. Please everyone join my Telegram channel to get the PDF of this session. 1 minute. I am going to give you the 5 questions with the hint. Wait for that. One minute. So this is my Telegram channel link, Electronics by Sanjay Rathi. Okay. So everyone please join that so that you will get the PDF of this session. Now, for the given circuit, what is the Thevenin's equivalent? Right, you have to determine the Thevenin's voltage VTH. VTH means, again try to watch this. This is a 2i. So don't worry. Number of students are highly confused with what dependent sources. So don't worry about the dependent sources. Open circuit means, what is the current here? 0. When the current is here, 0. This is the 2i. Now, if you want to find the current, you can use the mesh analysis or you can use the nodal analysis. You can use anything. But remember that if you want the VOC, write I or I2. Apply the mesh analysis, find the I2. What is the I2 and what is the VOC? This is nothing but Thevenin's voltage. It will become VOC is equal to 2 times of I2. Means we have to find the I2. Right? From this, what is the I will become I1 minus I2. And that's why 20i, you can say what is the 20i. Write down the KVL here, write down the KVL here, and you will get the answer within seconds. So this will become minus 2 plus, this is the minus 2 plus I1. This is the 1 into I1 plus 1 into small I. And what is the small I? I1 minus I2. Directly you can write. This is the KVL is equal to 0. Now this will become 2I1 minus I2 is equal to 2. It is the equation number 1. Second equation, this is the 20I plus 2I2 plus I2 minus I1. We are writing the mesh equation I2 minus I1 into 1 is equal to what? 0. What is the 20I? What is the I? I1 minus I2 plus 2 plus 1, 3I2 minus I1 is equal to 0. And then 19I1 Check my calculation, everyone, and that is the assignment for you. -20 plus 3, 17 I2 is equal to 0. Solve the I2 in terms of I1, put here, get the value of I2, and you can get the value of what? VOC, 2I2. So this is the way, mesh analysis. You can also apply the nodal analysis. Sir, I want to apply the nodal analysis. No issue. That is the VOC. You can apply the VOC here and you can solve this question by using the nodal analysis also. You can apply the nodal or mesh or anything. Try to solve this question, right? That is the first assignment and that is the given hint by me. Second hint I want to give, always remember, if it is a VOC, then what is the voltage at this point? This is the 20I and this is the VOC, so it will become 20I plus VOC. Yes, easy, 20I plus VOC. Now what is the I? I is nothing but 20I plus VOC divided by 1. You can say this is the 19I plus VOC is equal to 0. So what is the I is equal to minus VOC by 19. First relation. Solve. Then you can apply KCL at this point and directly you are able to 20. I put the value of the I here and then you can find the value. Easy, guys. You can use any method. Solve this particular question. This is called nodal equation. Write the nodal here and you will get the answer for this particular question. And in this way we can find the value here. So this is the first assignment. This is the second assignment. Now watch this sinusoidal signal. Circuit shown at resonance. The amplitude of the sinusoidal voltage across the capacitor. This is the question on what? Resonance. In resonance, inductor and capacitor, combination of inductor and capacitor will act as what? Short circuit. This is the inductor and this is the capacitor. Both will act as what? Short circuit. And voltage across the inductor and voltage across the capacitor have the same amplitude. VL is equal to what? VC. When VL is equal to VC, what is asked here? At the resonance, the amplitude of the sinusoidal voltage. Amplitude of the sinusoidal voltage. I am giving you the hint. That is nothing but Q times of what? VM. What is the Q? Quality factor. And what is the VM? This is nothing but VM cos of omega t. VM is given 10 volt. You have to find the quality factor. What is the quality factor? Omega naught L by R. Omega naught L by R. And what is the omega naught? 1 by root over LC. 1 by root over LC. Value of 4 ohm is given. Point is given. 1 microfarad is given. You can find the value of omega naught. You can find the value of quality factor and then use this formula to get the voltage across the capacitor. So this type of questions, that is the simple hint. Again, it is the assignment. And that is again the damping ratio of the series RLC circuit. In 2015, again 2 marks question. Damping ratio zeta, right? In series RLC circuit. This is the integration of what? Control plus network. Control plus network. Use the concept of control to find the value of the zeta. Damping ratio of the series RLC circuit. Assignment number 3. Try to solve. Please don't see the solution. I have idea that all the solutions are available on the net, on the different textbook. You have the solved question booklet, but try to solve these questions on your notebook. Don't try to follow the solution. If you are going to follow the solution, then you are not going to get the command over this topic. Remember that. Very, very simple. This is a very easy question. Assignment number 4. Finally, one question I am going to give you from the 2-port network. No doubt, tomorrow we will solve around 20 more questions on this topic. Okay then. This is the question from the two-port network, assignment number 5. Very, very simple. Find the Z parameter. This is the question of only 2 marks in 2001. What is the Z parameter of this diagram? Okay, guys. Then you are on BYJU'S exam prep, right? Thank you for attending the session. Thank you very much for your cooperation. You are giving the answer on the comments box. Everyone, please write answer for all the assignments on the comments box, so that I will mention your name on the next session, right? Like the session, subscribe our channel and share the link of this session. Thank you and good night.